Alright, let's work on the first problem of the day, which is LeetCode number 31, Next Permutation. A permutation is an array of integers. It's an arrangement of its members into a sequence or linear order. For example, 1, 2, 3 can be permuted to 1, 3, 2, 3, 1, 2, 2, 3, 1. Okay. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutations are sorted in one container, then the next permutation is a permutation that follows it in sorted order. If such arrangement is not possible, the array must be rearranged in the lowest possible order, sorted in ascending order. Okay. Okay. Let's see. Num's length is equal to 100, which seems to point towards a O of n squared solution, potentially. Because 100 squared would be 10,000. Or maybe O of n cubed. Right? Somewhere in that ballpark of polynomial time, it seems. The replacement must be in place and only use constant extra memory. Constant extra memory seems to point towards... Oh, and it's to return the unit. Okay. So we need to actually swap the numbers within nums so that it is the next permutation. So obviously, generating all permutations would be way too slow. I think the input size for that one was like 4 items max, which is, yeah. Let's see. You know, funnily enough, what I'm thinking about is like maybe something that is kind of like a quicksort. So what I mean is that we basically go through each number and swap it into place. It sounds kind of weird, but kind of reminds me of maybe that. So for example, if we had 1, 2, 3. 1, 2, 3, then you go to 1, 3, 2. Then 2, 3, 1 becomes 3, 1, 2. So for example, it goes 1, 2, 3, then 1, 3, 2, then 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1, I think. Let's see. 2, 3, 4, 5, 6. Essentially, you're just going in ascending order, assuming that they were like integers, right? So 123 is less than 132, which is less than 213, less than 231, 312, and 321. So in that case, what goes on between here and here? Well, we swap the middle and the right side, which is larger. Here we do a swap the first and the last. The min of the left side, or sorry, the min of the right side, right? Because we don't swap with 3. We want to swap with the next largest number, which in this case is 2, I guess. Then here we do a swap the middle and right side, which is larger again. Then here you do swap the first and the middle, the min of the right side that is still greater than first. And then you swap the middle and right side, which is larger. So it seems to me that first, I guess there are a couple of questions regarding this. So first, how do you know which tile to swap, right? You always want to make sure that the left side is smaller than the right side for sure when you swap. Unless there is no greater number, in which case you swap with the smallest number, right? Because wraparound. So we know that the left must be smaller than the right side, except in the case where the left is the largest item in the array. But how do we know which tile to swap? Let's see. Is there a way to calculate the number of permutations that are possible given n numbers? And if so, are they equally distributed across each number? So what I mean by that is like, okay, so 1, 2, 3, we can get 1, 3, 2, and then 2, 1, 3, 2, 3, 1, so on and so forth. We get 6 permutations exactly. Well, this is probably a no, because if we look at an example like example 3 where we do 1, 1, 5, we could get 1, 5, 1, and then 5, 1, 1. And I think that's it, right? Because we have a bunch of the permutations that are equivalent. So let's just return here. So for example, if I did 151, the next number should actually be 511. Because swapping the 1 and the 1 would be equivalent, right? Yeah. So, maybe start from the end of the array, and for each index, try to find the minimum number which is still greater than you. If 1 exists, then swap with it, and we're done. Otherwise, if we reach the end of the array and still cannot find, or the start of the array, a larger number to swap with, then we need to swap with the minimum number. And so this would be O of n time because we need to go through each one. This would be this would be 1 plus 2 plus 3 plus dot 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 plus n operations, which is O of n squared times O of n, which gives us the O of n cubed runtime. So I think this might actually be a potential solution then, because the runtime matches. I think it works. So the idea is that we start here, right? We start here, 3, nothing is here, so we don't touch it. Here, the 2, we find the minimum that we swap is 3, and then we go. And then here, the 2, nothing, 3, nothing. The 1, we find the 2, which is the minimum. We swap, and then 3, nothing, 1, we swap with the 3. Then 1, nothing, 3, nothing, 2, we swap with the 3. We swap with the 3. We swap with the 3 and the 2. Let's see. What if, rather than saying if we reach the start of the array, rather, if we cannot find a larger number to swap with, then we swap with the minimum instead, assuming that the swap will occur at another digit. So what I imagine is that, okay, so here we take this 3. So for example, okay, we start with this 2. Or we start with this 3. There's nothing after it, so it doesn't swap. We start with this 2. This 2 has a 3, so we swap it and we return. We're done. If we started here, 2 has nothing. The 3 has nothing here. But we swap with the 2 and we continue. We swap with the 2 and we continue. So now in the intermediate, we get 1, 2, 3. Then, so this is intermediate value. Then the 1 swaps with the 2 because it's the smallest of, it's the minimum of the numbers. So then we go 2, 1, 3, which is what we wanted, right? And same thing here. This 3 has nothing. This 1 stays the same. Does this stay the same? No, because it's the minimum. So we go 2, 1, 3. So that's a regular swap, right? That's a regular swap to a larger number. And then here, and then we just return because it's a larger number swap. Here, the 1 has nothing, the 3 has nothing, right? But then we switch to 2, 1, 3 as an intermediate, assuming that we swap a larger number at the end, right? And then we swap, then afterwards we swap with the 3, so 3, 1, 2 is our result. Because the 2 will then swap with the 3, which is the minimum of the numbers afterwards. Then we swap regularly with the 1 and the 2, and we end. And then here, let's see what happens. So 3, 2, 1. The 1 does nothing, but we go 3, 1, 2 as an intermediate. And then here we go 1, 3, 2. Right. We go 3, 1, 2 as an intermediate. Because the 2 swaps with the 1. The 2 swaps with the 1 and we get 3, 1, 2 because that's the minimum. And we continue. Then the 3 swaps with the 1 when realistically the 3 should swap with the 2. Because we want to minimize it. So this is incorrect. So maybe we want to swap with the leftmost item if we cannot find a value. The leftmost item less than itself. So the idea is that if we swap with the leftmost item that is less than itself, then we minimize the larger number to its lowest space. Let's see. 1, 2, 3. Right? And then we swap again. We try to find a larger number to swap. The minimum of the larger side, or the minimum of the right side, because that'd be the next one. And then in the reverse, if we want to go from the largest to the smallest, we have to sort of do things backwards, in the sense that we want to minimize the number. But that requires a lot more movement around. The 2 is actually in the right place in this case. I feel like I'm close to the answer, but there's just some nuances that I can't really get rid of. So the 2 is in the right place in this situation, so we don't really want to swap it. what we realistically want is to swap the 3 first. Maybe we just special provision for the max. So what I mean is that if the digit in the left-hand side is the maximum digit that we have within our array, which we can find in O of n time, then that means that we need to swap it with the minimum. Let's see whether or not this expands to, let's say for example, a larger example. So 1, 2, 3, 4. Then this becomes 1, 3, 2, 4. No. 1, 2, 4, 3. Then 1, 3, 2, 4. Then 1, 3, 4, 2. Then 1, 4. Blah, 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 so on and so forth. I think we get the middle parts, but what happens when we get to 4, 3, 2, 1, which is the maximum, right? Let me think. The problem is that we don't know that this is the maximum. We know that the 4 is the largest number in the array, but maybe just reverse it then? But we don't know because there's also like 4, 3, 1, 2, and so on and so forth. Maybe identifiable by if we have no additional, or if we have no valid swaps. So strictly decreasing, or just decreasing in general. So it's like 4, 4, 3, 2, 1, or something like that. Basically, if we're at the max and we can't swap anymore, then we just reverse it. That can be possible. I think this is a decent solution. Let's go ahead and code it up. This last part is really the only part that I'm feeling iffy about. I think the rest of the solution is pretty solid. But in any case, let's go ahead and code it out. So say we'll start by doing start with the reversal check. Also, there's an edge case here where if nums.length is equal to 1, return nums, or just return. Because we don't need to do anything if the number's length is 1. Then we can do the reversal check. So we can say var is max is, we'll initialize it as true. Then we'll say let me think. Nums for each number in nums. And we'll say like var current min is equal to nums at 0. If num is greater than or equal to, or if it's greater than our current min, then that's is max is equal to false. And then current min is equal to, or this should start off as false. If we have any number that is larger than our current min, then we set that there. And then else current min is equal to num. So the idea is that we find our smallest number so far. We find our smallest number so far so that if some other number is larger within the array after it, then we know that a swap exists and therefore that we are not at the max. And if current or if is max is true, then what we want to do is to do nums.reverse and then return. And the idea is that if we are at the point where we are at the maximum, then we just need to reverse the array. And then we'll have the correct answer. Otherwise, then we can do for reverse index in nums.size down to 0. So we do a reverse for loop, and actually this should be a size because we're dealing with a collection here, not a string. So for a reverse index in num size down to 0, we can say var min of right is equal to nums at reverse index. Var so this is the minimum of the larger numbers, larger than reverse index. And we can say -1, we'll start that there. And then otherwise we want to reverse it with an intermediate value, which is just the min, which also starts at -1. We'll say min of max, or min of greater. I think that would be more descriptive. And then we just have a general min. And then we can say for index in reverse index to nums.size -1. And this should be nums.size -1 because it's inclusive. So we run through this second loop, and we'll say if nums.size is greater than, or not nums.size, if nums at index is greater than min of, nums at reverse index, first of all, right? So if the number is actually bigger, and then we can say if min of greater is equal to -1, then we can say min of greater is equal to index. Otherwise, we need to check if nums at min of greater, or if our index here is less than the nums at min of greater, then we say min of greater is equal to index of greater is not -1, and nums at index is less than nums at min of greater. Then we don't need this else case here. Sort of shrink this down. So now we have if if our current index is like if our current index is greater than the index that we started at, and it either happens to be our min of greater, it happens to be -1, or it exists but our number is smaller than the other greater number. So the index that we're at is greater, or is smaller than our min of greater, but still larger than our starting index. Then we do that. And then we also want to say if nums at index, or if min is equal to -1, or nums at min is less than or is greater than nums at index, then min is equal to index. So if we don't have a minimum currently, or if the number that we're or if the number that that we're at is less than our minimum, then we set the new minimum there. Then outside we can say if min of greater is not -1, so if we have a number to swap to, we can say val temp is equal to nums at reverse index. Nums at reverse index is equal to nums at min of greater, and then nums at min of greater is equal to temp. Otherwise, if min of greater is -1, then we do the same thing, but we do it with the min. And here, if such a swap has occurred, then we return. Otherwise, we continue, but we swap with our min, assuming that something else will occur. And we don't really need this return statement at the end because it automatically will return. And I think that's it. Let's go ahead and let's see. So we start at the end. We have two values that we're interested in, either the minimum of values that are greater than us or the minimum in general. We will start checking at this index +1 until the end of the array. If the value at the index is greater than what we started at, if a min of greater doesn't exist, or if it does exist, but our index is smaller than that, then we set it to there. And also, if the min doesn't exist, or if we have a number in the min, but it's larger than what we are at, then we set the min to the index. Then at the end, we check to see if we can either swap with a larger number and return, or in the case that we cannot, swap with the minimum and continue. Because by swapping with the minimum, we basically say that, okay, we want to minimize this this part of our integer array, because we assume that the next digit may swap with a larger number, and that will be our newest greater number. Let's go ahead and do a run, and let's see. So we'll say, we'll do a print line, min of greater, print line min. So here, this should not do anything. Here, this should swap with the 5. So 5 swaps with the 1. And then the 1 swaps with the 5. But does it get that far? Interesting. Does it get tripped up by this? For each value num, so we set our current min to 1. For each num, 1 is not greater than 1, so our current min is 1. Then 5 is greater than 1, so isMax is not true. And then we continue. Let's see, is continue allowed? An allowed phrase in here. I mean, a for each loop is a for loop, right? Is it just not gonna? Okay, it's not gonna let me. That's fine. So the idea is that, so if we encounter a number that is greater than our current minimum, then we know that we still have a swap to do. Otherwise, we don't. Sorry about the noise, by the way. It's not -1. So here, so the 1 has nothing. The 1 has nothing. The 5 has a min of 1, or a min of 2, right? So it'll swap there. And then you have a min of greater, which is at 2. And then you swap there. And you get 5, 1, 1. Let's toss in a bunch of test cases and let's see what still breaks. Looks like we're good. Let's toss in the submit and let's see where we're at. Maybe there's still an edge case that we need to consider. Ooh, we got close, but not quite. Let's see, where did we go wrong? 2, 3, 4, 7. Let's see. So this should be 3, 4, 7, 5, 3, 2. The next number should be 5, because this is descending. So now you should swap with the next largest, which is 5. So that should be 5, 5, 2, 3, 4, 7. So this doesn't swap. You swap with you. So let's see. So 5, 4, 7, 5, 2, 3 is the first swap. Then 5, 4, 7, 2, 5, 3 is the second swap. Then 5, 4, 7, or 5, 4, 2, 7, 5, 3 is the third swap. Actually, is there a greater number? Let's see. Swap 3 and 2. Then this is swap see, swap. That swaps 3 and 2. 5 and 2. Then what's the next number that we need to consider? It's 7. Swap 7 and 2. Right? We'll do a print line min of greater, min of greater, print line min, min, and then we can say, and we generally know like sort of where it's swapping. So first one doesn't swap with anything. Actually, we could probably do this. Num size minus 2. Then we can do, so you swap with you, then you swap with you. So you swap 2 and 3, then 5 and 2, then 2 and then 7 and 2. So 1, 2, 3, and 4, and then you do 5, 2. Oh no, we probably check. So in that case, we probably swap. Let's see. Hold on. Okay, so I took a step back and thought about it a little bit more, and I think what I realized is that by checking the numbers, if we do not find a swap, that means that the numbers that we have encountered are in descending order. However, when we swap the numbers, we want whatever is after it to be in ascending order so that we start at the bottom, right? But we know that it's already in descending order because we haven't swapped within there. Now, when we swap with the minimum of greater numbers, that means that we are placing it in the order in which it should be, where the number should be within the context of the descending order subarray. So what we do after the swap is that we just need to reverse that subarray portion, and then that is the next permutation essentially. So it's a little bit weird, but I think it works out. And then we still have the provision case for the end, because I don't think that there's much that we can do in that case besides just reversing the array. Because that's just how it is, right? If it's in descending order, we just reverse it. In any case, I just ran through the test cases. I'm going to comment out this print statement. I'm going to submit it, and then let's see where we're at. I think this might make more sense than what we did before. Seems like we're still running into an issue though. Let's see, 3, 3, 1, 3. So this 3, so you swap with the minimum of greater numbers. So you swap, so you don't swap there. Why don't you swap there? If you swap there, then that is in, oh, it's already in ascending order. So it's not guaranteed to be in descending order. Well, if we do this, and if it's less than or equal to, then we can get the last number in descending order. So now, rather than swapping with this, it should swap with this. Huh. Yeah. So 2, 3, 1, 3, 3. So we want to swap with the last one so that it's always in descending order. And then we want to... Interesting. So we want to swap it there with this one. So then it's 3, 3, 1. Then we swap it so that that part is in ascending order. Why is that not happening though? Swapping 3 and 3, interesting. Oh, we want it to be greater, but if there is one that exists within the nums index, if there is a duplicate, then we want to swap with that one instead. So I think this should work. Interesting. Kind of stuck in pending. Did my internet go down or something? Or is LeetCode down? Oh gosh, if LeetCode goes down, then I guess we're done for today. That's the case. This is really weird though. I don't think I've ever seen it. I'm not gonna buy LeetCode Premium, but interesting. Let me just check here and like do like a refresh. No, my internet is still up. Is LeetCode down? LeetCode is not down. Why is this not working? Here's what I'm gonna do. I'm gonna control and copy this. I'm gonna refresh the page. Okay, saved. Let's take a look at the wrong answer again. And let's run through this input. And now it should be correct. Yep. Okay. Let's go ahead and throw in a submit. Okay, cool. And there you go. So basically the idea is that we check to make sure that the subarray is after us is in descending order. If it's in descending order, then we're fine. If we find a place where we can slot into and swap, then we should. And we want to find the minimum of that. Because we want to make sure that we don't break the descending order, right? And then once we swap, we know that that portion is in descending order, but we want it to be the next permutation. So in order for it to be the next permutation, then we need to swap or reverse that subarray. But that's going to be it for this problem. I hope you learned something, and I'll see you for the next problem.